All right, this is my third TensorFlow.js video, and I actually just a moment ago I made this list. So what have I done so far? I have made an introduction to where TensorFlow.js sort of fits into the kinds of stuff that I'm working on and thinking about. I made an intro video to the idea of what a tensor is and how to make a tensor, a variable that stores a tensor in your JavaScript code. And now, really what I want to do is I want to get down to, my goal is to get to the point where I'm remaking earlier machine learning coding challenges I did, but using TensorFlow.js as the basis for them, the foundation for them. So the things that I think that I need to mention and talk about before I get to that is I need to talk about variables and memory management. There's something different between a variable and a tensor, even though they're kind of a similar thing, but it has to do with memory management. I want to talk about operations, so mathematical operations that you can do on these tensors. The layers API, that's like the topic I'm the most excited about on this list. And so once I can do 3 more little quick general TensorFlow.js videos, which are by no means comprehensive as to everything that's in TensorFlow.js. It's a much larger API than what I'm going to cover. And also, I don't actually know any of this stuff. I'm just kind of figuring it out as I go. So I'm trying to talk you through me learning it. So just in case you're thinking you're watching a video by an expert, you're not. And then I'm going to get to these coding challenges. And then, I've teased this before, but there's a new library called ML5, which is built on top of TensorFlow.js, which I'm going to eventually do a lot of tutorials and videos and hopefully bring some guests in also to do stuff with ML5. Okay, so back to the computer. Where I left this off, I think if we look at this code that I had, is I created a tensor. I used tensor 3D because I knew the shape was going to be of rank 3, having 3 dimensions. Yes? And this is the shape. I'm putting integers in it. I'm console logging it. And we can see the result here. Now, incidentally, I think I should also note that if I actually want to look at the data, not just seeing it, the string of it like printed out there, then what I want to use is actually the data function. Oh, wow, I probably shouldn't have called mine data. So let's call it a tensor. Probably shouldn't call it that either. Let's call it tense. I'm very tense. Tense.data. Now, this is going to be a problem, I think. Let's see what happens here. And this is going to relate. I'm going to get to the point here. You'll see. Look at this. A promise. Oh, that's so nice of TensorFlow.js to promise me something. What are you promising? So here's the thing. There's something weird going on here. And this is actually really the topic of this with variables and memory management, in that something is happening here. Something is happening right here. These values are stored in a plain old array that's in the computer's memory. And when we make this tensor out of them, that data gets copied onto the computer's graphics processing unit, the GPU. That takes some time, and we want to minimize the amount of times we have to copy memory back and forth. So this is a thing we're going to have to think about as we build more examples in code. This here is doing this asynchronously. This here is doing this asynchronously. Now I wonder if I could give it a callback. I'm just going to experiment here. I think they're only using this thing called promises, which have I made a video tutorial about this yet? I really need to. So what happens if I give it a callback to see like, oh, can I give it a callback there? Oh, wait. So let's do this and see like, oh, let's give it a callback and then see if we can look at the stuff that comes out of the callback. Let's see what happens there. No, because I have too many parentheses. Yes, too many parentheses. No, nothing happens there. So it's not using, and Alka's telling me I could use await, but there's so much ES6 and beyond JavaScript going on here. So actually what I want to do is, if I say tense.data, I can say then. And then is this special function that's part of a promise, where it's saying like, once the promise has been resolved, you've made a promise to me, you're going to keep that promise. And when that promise comes to roost, cock-a-doodle-doo, I don't know, then can I just write code in there? No, I have to make a function. I can say console.log stuff. Is that how it works? Yes, oh, look at that. So there we go. We can see this is one way. But I actually don't want to deal with any of this. So because I want to just, so this is something that's going to come up. I was trying to avoid this. And there's also a keyword called await that I could potentially use. But luckily, there is also a function called data sync. So if I use the function data sync, you're going to see this here. What this will do is actually give me all the data back, but without wait for it to be done. So now we should be able to say, boy, I really am very tense. We should see, here it is, and then here's it. Now notice it all came back as a one-dimensional array. Okay, back to recap. This is what the tensor is, and this is the way that we're thinking about the tensor and how the data is stored, and the print function allows us to see that very easily in the console. If I want access to the data sync function will just give me all of that stuff, ultimately just as a list of numbers, because this idea of the shapes and the dimensions is really for us as human beings to think about and store it, but ultimately it's just a bunch of numbers. So I should also mention that in addition to data sync, there is also a get function. So if I were to say tense.get and I were to say 0, we would see I've got the number 80, which is right there. And if I were to say 1, I've got the number 41. And if I were to say 29, which would be the last one, I've got the number 47. So get is another way I can start to pull that stuff out. Data sync, data, and I need to come back. I really should add an addendum here, which is that in order to support this material that I'm covering, at some point I need to come back and make a video on promises and how the arrow syntax is often typically used with promises and this then function. So this is something I need to come back and do some additional content on, as well as await and async. Because if you want to work with this particular library, how these new ways of handling synchronous and asynchronous things in JavaScript are kind of key foundational elements. So I've got to come back and talk about this. I would suspect that Fun Function has some nice videos on these topics, but I don't know. So maybe I'll link to those in this video's description. Okay. Hi, so I'm back actually with a weird edit point because I just went down a rabbit hole of trying to figure something out about memory management, and I discovered that actually the memory management stuff makes a lot more sense to talk about after I've already looked at operations. So let's actually, I'm going to switch this order here, and right now in this video that you are watching, I'm going to talk about operations next. And then maybe I'll take a break and move on to memory management in the next video, something like that, okay? So let me come back and talk about operations. If I come back to the TensorFlow.js web page, there's actually a part of the sidebar here, part of the API, which is all about operations. And when I speak about operations, that's what I mean. Mathematical operations that I want to perform on the tensor itself. What if I want to double every number in the tensor? Or I want to take two tensors and element-wise multiply every number by every other number. What if I want to do matrix multiplication between those two tensors? Now, this would probably merit a whole video series about linear algebra and matrix math. Luckily or unluckily for you, I made a whole series about that already. So you could pause here and go and watch that. I would also refer you to the 3 Blue 1 Brown video series on linear algebra, which is excellent. So rather than get into the weeds of all of the mathematical pieces themselves, I just want to kind of like look at a few and see how you would use these. Okay, so let's, for example, say I want to use tf_add. So if I click on that, I can see, add two tensors element-wise, a plus b. What does element-wise mean? Well, what that means, just to sort of recap, is if I have two matrices, A, B, C, D, and I have another one, E, F, G, H, and I want to add them together and I want to see the result, element-wise means A plus E, B plus F, right? I just take the ones that are in the same spot and add them together. So we could do that right now in our code. And I could say, I'm going to call this tensor A. And this is a little bit silly, but I'm just going to make a second one that's with the same numbers in it. obviously I more likely would have two tensors with two different values. And then what I want to do is say TF, wait, how do I, let me look at this. A add B, sorry. So what I want to do is I'm going to say const C equals A dot add B, which by the way would be exactly the same as saying B dot add A. In this case, with other operations, the order of the matrix, the tensor, sorry, I shouldn't say matrices. So that really could play a role. So if I say A dot B, and I were to say A print, B print, C print, and I come back here and go and hit refresh, we're going to see, here's A, here's B, they're the same, and then every number is doubled, basically, because I took A plus B. So really, obviously, I should make two different random sets of numbers, but this is how an operation works. And depending on what you're doing, you need different mathematical operations. So as you can see, there are a lot of things. We could subtract, multiply, divide. There's maximum, minimum, modulus, power squared, difference. All these would be interesting to pursue, and I might come back and do more videos about particular mathematical operations. But really, I think just showing you add, hopefully now you could kind of like look at the documentation and see what each one does. I think it's worth at least doing, there's lots of other math functionality, but I think it's worth looking at matrix multiplication, tf.matmul, because this is a really key concept in building a neural network, how to do this weighted sum of all of the inputs and all of the weights passed through. You really need matrix multiplication if you go back and watch my other videos. So let's look at this one. So here we can see a.matmul. So really it's just another function, but we're going to run into an interesting thing here. What if I were to try, and I don't need to print, I'm not going to bother printing A and B. Let's just try this right now. So I'm going to do, wait, this would work. A dot multiply, MULB, because that's doing element-wise. A times, in this case, A times E, B times F, C times G. Let's go back, and I'm going to hit refresh. Oh, it worked. So I guess the way, oh, wait, of course it works. I forgot that I was doing element-wise. Of course it worked. I'm doing element-wise multiplication. I'm trying to demonstrate here that if I actually want to do matrix multiplication, which is a totally different thing, matmul, is that what it was called? Now, there we go. Oh, I love, this is like my favorite error. This is very similar. These are the kinds of errors you're going to run into all the time. We saw this before. Error. Matmul, inputs must be ranked 2, got ranks 3 and 3. When you do matrix multiplication, the number of columns in the first matrix, A, has to match the number of rows in the second one. And by the way, you can't even have like a, this is totally, you can't have a rank 3, you can't do matrix multiplication. So this, by the way, this whole thing is flawed because this is only going to work. So let's, if I have a rank 2 tensor or basically a matrix, a 2-dimensional array. So now, let's get a different error message. Now, error in math. So first of all, matrix multiplication is only for matrices in 2 dimensions, tensors in 2 dimensions. And then the error here is the inner shapes 3 and 5 of the tensors with shapes 5, 3 and 5, 3 are and transpose. So what's this error message about? To do matrix multiplication, the number of columns in the first one must match the number of rows in the second matrix. So actually in here this would work. This would actually work because these are 2 by 2, and so the columns here matches the rows here. And again, if you go back to my video on matrix multiplication, you'll see why in more detail about this. So, but just to follow up here, what I must do now in order to do matrix multiplication is I probably would have shape for A. I could transpose one of them, but let's do this first. So I'm going to do shape A, and then I'm going to do shape B. This is a good time to cover transpose, and shape B. And now this should give me something. There we go. There's my new matrix. And out of matrix multiplication, if I am doing, a 5 by 3 multiplied with a 3 by 5, I end up getting a 5 by 5 matrix, which is correct. Now, another way I could have done this, by the way, is if I use the same shape for both of them, if I backed in here, I should be able, let's do this. Okay, I should be able to say B dot, now let's just see what happens if I say B dot transpose. No. So here's the thing. Remember, these things are immutable. So even transposing it, I probably have to say const BB equals B transpose, and then I can do A dot matmul BB. And there we go. So what does transpose do with a matrix? Transpose, if I have a 2 by 3 matrix, we'll take that matrix and transpose the numbers into a 3 by 2 matrix. So again, I'm not doing anything of any value or meaning here. If you go back, you could probably go back as an exercise. If you want an exercise right now, go to my toy neural network, look at nn.js, go through all of the matrix math that's in that, and see if you can rewrite that with the TensorFlow, the TF operations. I don't know why you'd want to do that, but if you want to just do everything you could possibly do in this world, that's something you could try. And maybe I'll try to publish something which is like an answer key to that. I don't know. You could ask me in the comments, or somebody could make one, and then I could post it. All right. So I think this is about where I want to stop right now. Again, this is not meant to be comprehensive. I just want to talk through what are the pieces here. We know that there are tensors. Tensors are n-dimensional groups of numbers with we can also, those are immutable, they can never change. If we need them to change, we could use this thing called a variable. Maybe we need to see an actual scenario where we need that variable. Hopefully that'll come up in one of my videos in the future, but you could try it yourself. And then we can also perform operations. We can perform operations like take these tensors, take this tensor and add this one, or double this, or find the maximum number in this one. And there's plenty more. Matrix multiplication. So I encourage you to explore all of those, and maybe I'll come back and go through some of them as we need them. But I just want to give you an overview of what's there in the TensorFlow.js API itself. So in the next video, I'm going to talk about something very important, because I have not been paying attention at all to how, whenever I create a tensor, I'm using memory of the computer, and sometimes maybe I'm using memory that's in the RAM, sometimes I'm using the GPU memory. What's going on with all that? So I want to, in the next video, specifically talk about memory management and how to make sure, if I'm making all these tensors and doing all these operations, how to make sure I avoid having a memory leak. Okay, I'll see you in that video.